Hello everyone, and I welcome you all to today's video. Today we are going to look at several popularly used normalization method on data. We are going to understand these concepts by solving certain question of first internal test, part C, data preprocessing and feedback analysis. My name is Manas Pathak and I am a student of IIPS DAVV. So let's start. So the question says, discuss normalization methods. A. MinMax normalization. B. Z-score normalization. C. Z-score normalization using absolute deviation. D. Decimal scaling. Min-max normalization. This technique rescales values to a fixed range, typically 0 to 1. It preserves the relationship between values proportionally. Minimum and maximum value from data is fetched and each value is replaced according to the following formula. So in min-max normalization, it uses the minimum and maximum values in our given data to normalize the data, and all the data is normalized. All the values are proportionally normalized with respect to each other. The formula for it is x normalized equals to x minus x min upon x max minus x min. Here x normalized refers to the normalized value of the data. X refers to the value of data which is not normalized. X min is the minimum value of the data feature X in our given data, and max corresponds to the maximum value corresponding to our data feature X. The minimum value maps to 0, the maximum value maps to 1. Other values are scaled proportionally. It is commonly used when fixed output scale is required. Z-score normalization. It is also known as zero mean normalization. This method transforms values based on mean and standard deviation. It is useful when the data must follow a normal distribution. So, contrary to min-max normalization, the z-score normalization performs the normalization of data using the standard deviation and the mean. The formula for it is given here. The formula is v dash equals to v minus a divided by sigma a. Here v is the original value, v dash is the normalized value, a refers to the mean of attribute a, and sigma a is the standard deviation of attribute a. This method centers the data around 0 with a standard deviation of 1. The values do not have any predefined range. So this is one more difference of z-score normalization with respect to min-max, where in min-max the data is strictly normalized to between ranges 0 and 1, whereas in z-score normalization the values do not have any predefined range. Now let's understand a variation of z-score normalization where we use mean squared deviation instead of standard deviation. Z-score normalization using mean absolute deviation (MAD) is a variation of standard Z-score technique. Instead of using the standard deviation to scale the data, it uses the mean absolute deviation. So in this technique, instead of using the standard deviation, we use the mean absolute deviation, which is nothing but the average of absolute deviations of for each data point. This method is often used because it is more robust to outliers than the standard Z score. Since the standard deviation squares the differences which exaggerates the extreme values, the mean absolute deviation, which just makes the takes the absolute difference, provides a more linear scaling that is less distorted by the extreme outliers. It is used when we require a stable scale. Here the mean is 0, but the standard deviation would be greater than 1. So using the mean squared error instead of mean squared deviation instead of standard deviation causes the standard deviation for the normalized data to be slightly greater than 1. Here is the formula for the z-score normalization using mean squared error. As you can see, it is the formula is similar to the formula used for the standard deviation, but in case of mean squared deviation, the denominator is used as mean squared deviation, whereas in the case of normal z-score normalization, which uses standard deviation, the denominator consists of the standard deviation. So the process of calculating z-score normalization using mean squared deviation is very simple. In the first step, we calculate the mean of the data. In the second step, we find the mean deviation, the absolute deviations for each data point around mean. In the third step, we find the mean of this absolute deviation, and then we put all the calculated values in the formula to get the answer. Decimal scaling. This method normalizes values by shifting the decimal point. Each value is divided by a power of 10. Based on the maximum value in the attribute, normalized data ranges from -1 to 1. Mean and standard deviations are scaled by same factor. Decimal scaling is primarily used over other normalization methods when a simple, computationally efficient transformation is needed and the relative magnitudes of the original data values as power of 10 are meaningful. So in decimal scaling, we divide all the data values by a certain power of 10. Now that power of 10 is decided by considering the maximum absolute value in the data. The maximum absolute, if we find the maximum absolute value and the number of digits in that maximum absolute value would be the power of 10. So here is the formula for that. So this was all about today's video. I hope you learned something from here. If yes, then consider liking this video and subscribing to my channel. I'll see you in next video. Thank you.